Hi, if you're watching this video, you're watching the first lesson in algebra. So in this lesson, we'll be reviewing some of the simple algebra you've covered in previous years. From there, we're going to take it to two-step algebra where it's going to involve a few more steps. So just follow along. Algebra sounds like it's going to be hard. It's going to be tricky. A lot of people talk about how difficult algebra is. It really isn't. The challenging thing about algebra is knowing and understanding the operations that you are using. In order to be good at algebra, you really need to be good at multiplying, dividing, adding, and subtracting. And if you're good at those, algebra is very, very easy. And one thing I notice is when kids say, oh, I'm not good at algebra, it's because they're not good at multiplication or they're not good at division. So if you're having trouble with algebra, just pay close attention to this video, watch it at your own pace, and review some of the stuff you may be having trouble with. So, algebra is math that involves variables, right? Variables. What's a variable? A variable is used as a letter or a symbol to represent a number, right? So you may have seen x equals or y equals, and these are all examples. These are all examples of variables, right? X and y are meant to represent a number. Now, it could be many different numbers, right? X could be 4 or could be 8. Well, if you don't know which one it is, you'd use X to represent that it could be any of those numbers, right? As a random example, right? Same with Y. Just because it's a different letter doesn't mean it's not a similar vein, right? It's still a variable. It could be any other number. The reason why you'd use different variables, different symbols to represent numbers is to say, well, X is not Y. They're not the same number. So these are two different numbers, but they could be any other number. They could be any number. So, for example, how do we solve variables? Equations with variables can be solved very easily, right? 3 plus x equals 6. Well, what is the value of x? So a lot of algebra is going to say find x. Well, to solve this, you will want to have the variable by itself on one side. Now, you may be looking at this being like, I don't need to do anything. I know this already, right? 3 plus 3 is 6. That's easy. But this is an easy example to show you how to do it for harder ones. So let's pretend we didn't know. I want x all by himself, right? I want x all by himself. So how do I get x all by himself? Well, what I do is I need to get rid of the 3, right? If I look on the equal sign, if I look at the equal sign, I want x on one side, I want x on this side, and I want everything else on this side, right? I want x on this side of the equal sign, and I want everything else on the other side. Or the other way around, it doesn't matter, as long as x is by himself. So right now I have 3, and I don't want that 3 there. So this is the same as saying 3 plus x equals 6. To solve this, I need to remove the 3. How do I remove the 3 to get x by himself? Well, I do the opposite operation. 3 plus x. Okay, well, I have 3 and I'm adding, so I do the opposite. I subtract 3. Well, if I have 3 apples and I take 3 apples away, I have no apples, right? 3 minus 3 is 0, so that turns into 0. However, whatever you do to one side, you must do to the other side. So if I subtracted 3 on this side, I must subtract 3 on this side, right? So then 6 minus 3 is 3. X equals 3, right? That's really easy. You look at the operation, you go, what operation am I doing? And you do the opposite of that with the same number. That way you get rid of it, right? Right? Because 6 minus 3 is 3. This is 0. X is now by himself. X equals 3. And that's how you do it. So pause the video and try these questions. All right, hopefully pause the video because I'm going to solve them, right? We have 10 equals x plus 5. Now, your good old math brain is probably like, I already know 5 plus 5 is 10, but let's pretend we didn't know. I have x on this side, and I want x by himself. What's with x? 5, right? I'm adding 5. So I want to get rid of adding 5. So what do? I subtract 5. Well, whatever I do to one side, I do to the other side. 10 minus 5 is 5 equals x, right? Because they cancel out. Plus 5 minus 5, nothing happens. So x equals 5. Easy. Okay, what about this one? 4 equals x minus 2. Again, something minus 2 is 4. We already know 6 minus 2 is 4, but let's pretend we didn't. We have 4 on this side. We have x minus 2. I want to get rid of the minus 2. I have x, but I want him to be by himself. So I have minus 2. So if I'm taking away 2, the opposite of taking away 2 is adding 2. Oops, that looks like a 3. That's a 2. Let me fix that. A 2, right? Minus 2 plus 2 is 0, so they cancel out. But whatever I do to one side, I have to do to the other side. So I add 2 to this side, because I added 2 here. So 4 plus 2 is 6, right? X equals 6, or 6 equals x. And that works, and you can test your answer, right? Because if this is true, then if I were to substitute, replace my x with 5, 5 plus 5 is 10, it'll work, right? If I replace my x with 6, 6 minus 2 is 4, it works, right? 6 equals minus 5 plus x. Oh dear. So what do? I have minus 5 plus x. Okay. Well, again, I want x by himself. I have minus 5, and I am adding. So I do the opposite operation, right? So I am going to take away instead of add, and I'm going to take away minus 5. Right? If I take away minus 5, I'm taking away the whole negative. So whatever I do to one side, I do to the other. Right? I'm going to take away minus 5 minus negative 5. Well, if you're taking away negatives, you're becoming more positives, right? And that's a tricky thing with integers. If you're taking away negatives, you're becoming more positive. You're taking away the bad. So you're becoming more positive, right? So this is basically just like saying adding 5. So that would make it 11 equals x. And you can test your answer. Put 11 into x, right? Right? You can put 11 instead of here, and you can go minus 5 plus 11. Well, that would be 6. Okay, what if you were multiplying? Right? What if you see 3x? Well, when you see something like this is the same as saying 3 times x. So is this 3x is the same as saying 3 dot x. And now, as you do more algebra, you won't see x as the multiplication symbol because x will be used as your variable, right? So you're going to see the dot, or you'll see 3 next to the x, 3x, right? So this is saying 3 times x equals 9. 3 times x equals 9. Once again, we do the opposite operation to get x by himself. Here we have 3 with that x, and we're multiplying. I want to get rid of the 3. So I'm multiplying, so I have to do the opposite operation. The opposite of multiplying is dividing. So I divide by 3. 3 divided by 3, they cancel out. Now x is by himself, but whatever I do to one side, I do to the other side, so I have to divide this side by 3. 9 divided by 3 is 3. X equals 3. And I can test my answer. I take this 3, and I drop it where the x is. 3 times 3 is 9. It works. Right? So try these. Pause the video and try these. All right, so hopefully pause the video. So 5 times something equals 35. Again, you already know that it should be 7, but let's pretend we didn't. Okay, 5 times something is 35. All right, so then what I want to do is I want to divide this by 5 because I'm multiplying by 5, which will cancel out my 5s, right? But whatever I do to one side, I divide this by 5. 35 divided by 5, x equals 7. Right? Easy, and you can test your answer. 7, plop that here, 5 times 7, 35. 7 times something is 42. Okay, well, I have 7 times x, so I'm multiplying by 7, so I want to divide by 7, which will cancel, right? Whatever I do to one side, I do to the other. Divide by 7, right? X equals 6. Right? Now this one might be a little bit challenging, right? You have 12 times something is a smaller number, right? 12 times something is a smaller number. How would you do that? Well, let's give it a shot. I'm multiplying by 12, so I divide by 12 equals, well, whatever I do to one side, I divide by the other, or I do to the other. So 6 divided by 12, x equals 6 over 12. But am I done? No, I can simplify, right? Equals 1 over 2, right? Or x equals 0.5, right? And you probably see where I'm going with next. What if we're dividing? Well, when dividing, just as a quick note, you can write your question like this or like this. It's the exact same thing. It's the exact same thing, right? Remember, I said earlier in fractions is that fractions and division basically are the same, right? If I were to say 8 divided by 2 equals, sorry, I put that in the worst spot, equals 4. Well, if I go 8 divided by 2 equals, right, 4, they're the same. It's the exact same thing. It just looks different. I like writing it like this, and later in math, you will see this. You will no longer see this as very often, right? You will very rarely see that division symbol. You will see this. Okay? So how do I get x all by himself? I have x divided by 4 equals 2. Okay. Well, in order to do that, right, I do the opposite operation. Once again, you do the opposites, right? So I'm dividing by 4. So the opposite of division is multiplying. So I multiply by 4, right? Which will cancel and cancel. But whatever I do to one side, I do to the other. 2 times 4 is 8. X equals 8. Right? So try these questions on your own. All right, hopefully you paused the video. Something divided by 12 is 3, right? Something divided by 12 is 3. Well, what I want to do is I'm dividing by 12, so I do the opposite operation. I multiply by 12. Cancel, cancel, right? Now x is by himself, but whatever I do to one side, I do to the other, times 12, right? Which would make this 36 equals x. Right? X divided by 5 equals 4. Okay, well, divided by 5, multiply by 5. 5 times there, cancel, cancel, times 5 here, because whatever I do to one side, I do to the other. Right? So what I'm going to do is I'm going to go x equals 8 times 5, right, is 40. Right? And this one, x divided by 4 equals 4. Well then, times 4, right? Because I'm dividing by 4, which cancels and cancels, right? 4, whatever I do to one side, I do to the other side, so I multiply by 4. 4 times 4 is 16, right? So x equals 16. Okay? So try these practice questions. This will help you review your algebra skills from previous years because this is a core skill. This will show up again and again and again. And all algebra is this, right? Future algebra will be just stuff like this, but instead of just being one step, instead of just dividing by 12, you'll be subtracting and adding. You'll be doing more than one step. But as long as you do each step one step at a time, you should be fine. So please watch this video, review the notes, do these practice questions. They will help you understand algebra more. Thank you for listening, and I'll see you next lesson.